Hello everybody, this is Todd Frazee, and this is the Multi-Axis Indexing CAM Strategies by Todd Frazee with Sierra College. This lesson covers an overview of using the Fusion Multi-Axis tab to apply three-axis CAM strategies to multi-axis indexing machining, also known in Fusion as 3+2 machining, which actually includes both 3+1 and 3+2 indexed part setups. The 3+2 technique allows you to position a workpiece using the three linear axes and up to two rotational axes, enhancing machining precision and reducing the need for multiple setups. By utilizing the multi-axis tab in Fusion 360, you'll learn how to control the tool orientation and generate toolpath that index the rotary axis of the machine into position. Objectives. By the end of this lesson, you'll be able to navigate the Fusion Multi-Axis tab to apply CAM strategies to multi-axis indexed setups. You'll be able to control orientation within Fusion to create toolpaths that index a CNC machine's rotary axis into the correct machining position. You'll also be able to model CAM in 5-axis CNC mill applications to industry standards and apply CAM in 5-axis CNC milling applications to industry standards through the laboratory and programming exercises. Rotary axis indexing, or 3+ axis machining. The rotary axis indexing enables the workpiece to be rotated to position or indexed for 3-axis machining. Over on the right, we've got an example of a 4th axis, looks like a Haas rotary, and they've made a horizontal tombstone with what appears to be 10 stations. It's cutting multiple parts per station and appears to have, it looks like mighty bites, holding down work pieces in 2 different stages of operation. So this allows us to do all these 3-axis moves at different angles on the faces of this multifaceted fixture. This increases the amount of cycle time so the operator can do other things. So for example, every time this stops, I would imagine they're taking operation 1, what would be operation 1 parts on a vise, taking op 2 off, that's finished parts, putting the op 1 components in those places, and then loading new blanks. While that's running, the operator could be deburring or doing secondary operations on those parts. The rotary axes do not move simultaneous with the linear axis in indexing. So the part rotates index to position, like on this 5-axis dual rotary table, and then it just drills in location. So the actual machining moves are all 3-axis. Here's an example of a cone shape. This is a screenshot of HSM, which is the same kernel as Fusion 360. But as you can see on this cone shape, all the Fusion, it's a drill bit, which is a 3-axis move, and it's positioning with the rotary so that the drill bit is normal to the given location of the hole. It does its drill, and it pulls out, and then it rotates. All the Fusion milling strategies that can operate in a 3+2 mode, except for those that are specifically for 4-axis and 5-axis. Those don't have the option because they can move full 4 or 5-axis simultaneously. So every single command you've learned, from pocket to 3D adaptive 2D adaptive, drilling, all of them have an option to be full 3+2 operations. And this is how we achieve this, is through the multi-axis tab. And it has supports 4 different types of machining. Our default on most of them is called 3-axis. That's used for 3+2 machining. Use the tool orientation group in the multi-axis tab to set the orientation you want to index the part before applying the rest of the tool path. So it's a little checkbox that says tool orientation, and you check that, and the options shown on the screen appear. It's not covered in this unit, but in the next unit we'll be covering wraps. Some of the commands in the 2D mode can be wrapped around a cylinder. For this, you do have to have a 4-axis rotary, and you do have to set up the WCS to be on center of rotation of that object for it to follow the cylindrical shape. I believe this is packaged separately than some of the multi-axis commands that are similar that work in 4th axis because there are different pricing structures if you're paying for the software. So the wrap commands are, I believe, all 2D commands that are in the 2D command structure. If you look in Canvas, I have a breakdown of every command and what modes it can work in under machining type. If we look at the Canvas for this unit, there's a table that I've created that has the command for multi-axis capability by command. So as you see, pretty much all of the items, all of the commands have the 3+2 checkbox by them, except for your advanced multi-axis commands that are using full 5-axis. So this is a lot of commands that you have at your fingertips that you can run on a 5-axis up to a 5-axis machine to do all of these operations, but they just operate, most of them just operate so that they index to a position and then commence whatever work they're doing. There are the 4-axis wrap, which are all 2D commands, and they are limited in truly there are 4-axis moves, but it's a software packaging where there are packages where you can get the 3+2 and the wrap commands, and then you have to pay extra for 4 and 5-axis if you are paying for the software. You're not. You have all access as a student. The next machining type is 4th axis, so it has some simplified setup information for the rotary, but again, you have to have, for this to function, you have to have this rotational axis aligned because it's doing the work on a perfect cylinder. We do have the collision avoidance box, which is not on the wrap, and it allows you to put some parameters that'll keep the tool holder from colliding, and it'll output additional rotation commands that hopefully keep you from colliding with the fixture. And then we have our full 5-axis options. Some commands actually can be operated in 3 or 4. The 5-axis machine running in the 4-axis mode is only going to rotate one of the axes for rotary motion, and could position with the other, but it's only effective, those commands are only effective if the shape is very cylindrical in shape that you're cutting and is in line with one of the primary rotary axes. Alright, so our focus today is going to be on setting this tool orientation for a pocket. We're going to do a little demo. You also have several assignments that use drilling cycles, pocking cycles, contoured cycles that you're required to set the tool orientation to rotate the rotaries in the right orientation to cut the part. Okay, so how the tool orientation tab works is the z-axis work coordinate system defines the default orientation of the tool with a cutting plane normal to the z-axis. The tool orientation can be set by the tool orientation set by the WCS can be overridden using the tool orientation settings. So multi-axis capable machines will rotate so that the tool orientation is normal to a fixed cutting plane using 4-axis or 5-axis indexing, which is also known as 3+1 and 3+2. Now, terminology for fusion, they don't differentiate between 3+1 and 3+2. All the commands are under the group 3+2, even if you only rotate one of the 2 rotary axes. All right, we're going to transition into a fusion demo. We're going to take this part that's part of the standard tutorial package that comes with Fusion 360, and we're going to set the tool orientation for a 3+2 move to cut the pocket of the plus symbol you see on this part in the image. A quick tutorial on how to set the orientation for 3+2 machining, or what is called 4 and 5 axis indexing. We're going to use one of the standard files that Fusion gives you. So you're going to go open your file structure by hitting the Rubik's Cube looking, it's called the data panel. And you want to go to basically your home screen, and we're going to scroll down to where it says cam samples. So make sure you're at the root directory and not recently used. Okay, we're going to double click on cam samples, and we're going to go into tutorials, and you're going to scroll down till you see one that's called tutorial 3. Should be this blunt pyramid looking shape. Now we can go ahead and minimize the data panel so you can see it. So our default orientation, if we're doing this, is a 3-axis part. You have your Z orientation as neutral of the table. So if we were to go to setup, and edit this setup, we see our current stock right now is set up as the body, and we're just going to keep all of this at default, and you can set your program and coordinate system. After that's all done, say the origin's top center here, and we're on a 5-axis machine. So we set the origin at the top and centered on the table, and we're going to cut this pocket on the right hand side. So in order to do that, let's select a 2D pocket command, and we're going to select, it looks like they already have some tools in here that are attached to the file. So we'll go ahead and select the flat end mill. And it does appear we're working in metric units. That won't really matter for what we're doing here. What we're focusing on is the second tab here called multi-axis. So we're going to accept our tool as default, pick on the multi-axis tab, and for the pocket command, you actually have a wrap function where you could wrap this around a cylinder. But we're going to stay in 3-axis mode, but we're going to use our tool orientation so that we can rotate our 4 or 5-axis table to be normal to this pocket, and then we can apply our pocket command. So to do that, we have different options here. You can do model orientation. This is very similar to setting the orientation for your stock. You could set up another WCS. I have done that in some places where they want a separate offset for every face so they can make adjustments. There's Z-axis plane and X-axis, as well as Z-axis and Y, just like there is for setting your stock initially. We also have X and Y axis, and we could go with a coordinate system, and there's component orientation. That was if you're trying to machine a component in an assembly mode, which I don't recommend doing. Okay, so unless you're just, it's the way it's built as a weldment or something. So we're going to use Z-axis plane and X-axis. We're going to select on the same axis as our pocket here. And you notice now the Z-axis, which is the orientation of the cutter, is now pointed normal to that face. Now if we want to make sure that this thing orientates the way we want, we're not sure if the X and Y plane is where we need it to be. And I just realized I can't use the X-axis with the, well, yes I can. I can pick an edge on the edge of this pocket, which should orientate the X-axis in line with it. I'm going to flip it over so it's pointed the direction I want. If you did want to move the origin, which again I don't really recommend doing, your 5-axis machine should just rotate it in orientation. You could do so by selecting set up WCS origin, and then you would select a new corner for that. On older machines you might have to do that. With the newer machines and dynamic coordinate system and tool offset, it allows you to do that without resetting the origin. Now you can also do an accessibility analysis. When you select that box, it displays everything in green that you can machine from that angle and everything that would be an That's a pretty handy tool. So the inside of this oval shape cannot be machined from that edge. Inside of these holes can't, and the faces in the bottom cannot. But what we're more concerned with is, okay, can I machine the inside of this pocket? Alright, and then we can go to our geometry tab, and in this case we're going to cut this pocket. You can set your heights. You notice the planes are all in orientation to your part now. That same normal parallel to the cutter. For demonstrations I'm going to leave all that at default, including the passes and the linking tab, and we'll go ahead and hit OK. And now we have a helical plunge in the center, and it does just a normal 3-axis milling job, but it is rotated the part in the angle we want. In effect, any of the 2-axis and 3-axis tools you can do this same function with by just setting the tool orientation. Okay, welcome back. I hope that demo helped you out. And again, you can apply those principles to the majority of the Fusion 360 commands. Okay, in summary, this lesson covered an overview of using the Fusion multi-axis tab to apply 3-axis strategies to multi-axis indexing machining, also known in Fusion as 3+2 machining, which includes both 3+1 and 3+2 indexed part setups. The 3+2 technique allows you to position a workpiece using 3 linear axes and up to 2 rotational axes, enhancing machining precision and reducing the need for multiple setups. By utilizing the multi-axis tab in Fusion, you learned how to control the tool orientation and generate tool paths that index the rotary axis of the machine into position. By the end of this lesson, in conclusion, by the end of this lesson, you learn to navigate the Fusion multi-axis tab, to apply CAM strategies to multi-index setups. You learn to control tool orientation with Fusion to create tool paths that index CNC machines' rotary axis into a correct position, and model CAM in 5-axis CNC milling application to industry standards, and apply CAM in 5-axis CNC milling applications to industry standards in the activity lessons in this unit.